Hey guys, this is Miss Mo. I know the paper says 14.5, but it's supposed to say 13.5. My bad. So the 13.5 notes are the ones that say 14.5. Okay. Anyway, in 13.5, we learned about volume, mass, and temperature. Nothing crazy, pretty much just a bunch of formula work. So let's look at this sucker. It says we have a right circular cone, and it says the volume is blah, 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 type an exact answer in terms of pi. Okay, so let's see here. First, let's look for the formula for a cone. Here's the formula for the cone. That's a cone. Okay. But then we have half of a sphere. This thing at the top, it's half of a sphere, or a hemisphere. It's half. Okay, so for the sphere, we're going to have to use this 4/3 pi r cubed. And then, after we do the 4/3 pi r cubed for the sphere, we're going to divide it by 2, because this is just half of a ball, or half of a sphere. So the volume is this formula, but then we got to divide it by 2 for the half sphere, or the hemisphere. Okay, let's go. It looks like my R is 8, and this 19 is the height. Yeah. Or if you look over at this picture of the cone, R is from the center to the outside of the circle, or for us the 8, and then H is the up and down piece of the cone, or for us the 19. Okay, so let's see here. To find this volume, we're going to say pi times the R, which is 8, squared, times the H, which is 19, all over the 3. And then let's work on this slowly. The top is going to be, let's see, 8 squared is 64, times 19 is, 1216. And all I did were the numbers. So let me just write down that pi afterwards. All over 3. Okay, now let's see if we can reduce this. 1216 divided by 3. Oh, yeah, we can't do that. Darn. Okay, so this is just the volume of the cone. It looks really gross, but if I were to put it in a decimal, it wouldn't look as gross. Okay, so this is the volume of the cone. Now let's do the volume of the hemisphere. So we're going to have 4/3 pi times the R of 8 to the 3rd. Okay, and that makes 4/3 times pi times 512. Okay, then we're going to multiply the 4/3 and the 512. In your calculator, you're going to say 4 times 512 divided by 3. Whoa! Okay, and it does not turn out to be pretty. So this is pen. All this is pen. So, let's just keep it nasty. We're going to say 4 times 512 is 2048. That's the 5 times the 112. So because everything gave me a decimal, we're just going to turn it back into a top-heavy fraction. Or 4 times 512 is 2048 on the top. On the bottom, we still have a 3. And on the top, we also have a pi. Okay, so this is the volume of a full sphere. But then we need to divide this by 2. So we're going to take 2048 pi over 3 and divide it by 2. Okay, remember when I do division and fractions, I do keep, change, flip. So I keep that 2048 pi over 3. I change the division to a fat multiply. I flip that 2 upside down. And that 2, when I flip him upside down, there's a 1 underneath. I pretend, so it becomes 1 over 2. And let's see what this gives me. When I multiply left or right, I get 2048 pi over 6. And let's see if that reduces. 2048 divided by 6. Ah, poop. It doesn't. Okay, so we got the volume for the cone. It's this 1216. We got the volume of the sphere. Then we had to divide it by 2, which ends up multiplying it by 1/2, and we got 2048 pi over 6. And we want the volume of the whole thing. So now we're going to plus them. So we're going to take that 1216 pi over 3, and we're going to plus this 2048 pi over, what is that, over 6? Okay. But y'all know, so our first step was to find the volume of a cone. Second, volume of a sphere. Third, divide that sphere by 2. Fourth, add your 2 volumes. Okay, so now if I try and add them, I can't because I need a 6 on both of my bottoms so that I can add them. So I'm going to multiply the top and the bottom by 2, and that'll get me that 6 on the bottom that I'm talking about. Okay, so it looks like I have 2432 pi over 6 plus 2048 pi over 6. And now let's add those. To add fractions, you add the top and we get 4480 over 6, and there's still a pi on the top. Okay, let me see if 4480 can finally be divided by 6. Oh my gosh, no, it's still a decimal. Poop. Okay, so we're just going to keep it as 4480 over 6 unless we can reduce. I think we can reduce by 2. So our final answer is 4480 divided by 2. 240 pi over 6 divided by 2. 3. Yeah, and that's super gross. But if we look at the answer box, it says type an exact answer in terms of pi. So I still have the letter pi. Done. Use integers or fractions. That's what we used, fractions. Okay. So the volume of this is this. If we wanted to figure out what it was as a number, we could say like 2240 times 3.14 divided by 3, and it's about 2,344 centimeters. And now since we're on volume, we're going to say centimeters cubed. So area was squared, now we're on volume. Okay, let's look at this part B. Part B says right triangular prism. Here it is. Let's look for a formula. Okay, it looks kind of like this guy. Kind of looks like a tent. Yeah, let's do it. The volume is base times height times length divided by 2. Okay, so this picture says the base is along the bottom of that front triangle. So for us, 6. The height is the up and down of that front triangle. It's kind of like where you would walk through the end of the tent. So 6 times 6. Then the length is how long it is, or how long the tent would be. And this tent is just 10 centimeters long for a bug. Okay, then it's divided by 2. Now let's multiply what we can. 6 times 6 is 36 times 10 is 360 over 2 is 180. Okay, so we were supposed to find the volume, and it's 180 centimeters cubed. And it's cubed because it's three-dimensional. We multiplied three numbers together. It's three-dimensional. Okay, it also says something about type in exact terms, pi. Well, we didn't have the pi written anywhere here. So pi is not in the answer. Pi is only in the answers if you have like a circle or a cone or a cylinder, something with a circle in it. Yeah, that's when you have pies. If you don't have the circle on your picture, there's no pi in the formula. Okay, let's look at part C. It says a right circular cone. Okay, well this time it's just the cone formula. So we don't have to add the cone and half of a sphere. We're just doing the cone formula. V equals pi r squared h over 3. Okay, r is from the center of the circle to the outside. So this is pi times 3 squared. H is the up and down. So 4 over 3. Okay, now we're going to deal with just the big fat numbers. 3 squared, that's like 3 times 3 is 9 times 4. Let's see, that makes 9 times 4 is 36. So we have 36 pi on top. On bottom we have 3. And now let's try and divide these. 36 divided by 3. Is it a whole number? Oh, yes! Yes. Okay, so we divide by 3 because we reduced, and we just get a big fat 12 and a big fat pi because there's still a pi on there. And the little answer box says type an exact answer in terms of pi. So we did it right, 12 pi. And then that little drop down box, it's centimeters, but we're three-dimensional now, so cubed. Okay, let's look at D. D is a sphere. Okay, well first let me get the formula. V equals 4/3 pi r/3. R/3? Yeah, I got it from right here. Sphere. Okay, and let's see, it looks like R is this ocho, and then pi is just a symbol. So let's go ahead and plug in our goodies. We're going to have, I'm going to go sideways because I kind of ran out of room. 4/3, then there's a pi, then there's a R, which is a 8, and it's to the third power. Oh gosh, okay, let's see here. So A times A times A, 512. So this makes 4/3 pi times 512. Yeah. Okay, and then now we're going to try and multiply and divide this. Maybe we can do it. If we can do it, we would do 4 times 512 divided by 3. It's a decimal. So instead, let's use the fraction. 4 times 512. 4 times 512. 2048. Okay. So we got 2048. And we got that from the 4 times 512. And it's still all over 3. And then we have a big fat pi on top. Yeah. Okay, so that's the volume of that sphere. And we're still centimeters. And we're cubed because it's three-dimensional. Alright, let's look at this sucker. It looks like a cylinder with a half a sphere on it. Or like an observatory where they have, you know, like a big telescope, and whoosh, whoosh, they look at the sun and the earth, or the sun and the moon and all that stuff. Anyway, okay, let's go. Cylinder. Formula for a cylinder is right here. V equals pi r squared h, where r is in the circle, h is on the side. Okay, let's see here. So we're going to have, for the cylinder, we have pi r squared h. Okay. For this hemisphere, the formula for sphere is 4/3 pi r cubed And then, because it's only half of a sphere or a hemisphere, we're going to divide by 2. Yeah. Okay, so let's see here. First, we have to figure out our R. Okay, well, it says that 80 goes all the way across. That's not our R. Our R is whatever that is divided by 2. So R is only from the center to the outside, not from one side to the other. So our R is 40 here. So let's go ahead and plug that in. We're going to have pi times 40 squared, and then our H, they gave it to us. It's this 100. If you want me to write it down, I will. H equals 100. Okay. So let's see here. 40 squared, I think that's 1600. Yeah, okay. So 40 squared is 1600 times 100. That makes 16 with 4 zeros. Or 160,000 with a pi on the end. Okay, so that's the volume of the cylinder. Let's look at the sphere. We're going to have 4/3 pi, and our R is 40, and it's cubed. Let's see what 40 cubed is. 64,000. So this is 4/3 pi times 64,000. Okay. Okay, if I try and put in just the numbers, as in 4 times 64,000, enter. Then if I try and divide it by this 3, let's see what happens. Oh, decimal. And it doesn't say anything about a decimal in this answer choice. So I think I'm just going to keep it dirty and do 4 times 64,000. Bam, write that down. 256,000, and it's all over 3, and we have a pi right there. Okay, so for that, I multiplied the 4 times the 64,000, and I got that 256,000. Then I wrote down the 3. Okay, so my first step was to find the volume of the cylinder. My second, the volume of the sphere. My third is to now add those two together. So my third step is to take that 160,000 pi plus 256,000 over 3 pi. Okay, well, to do that, we have to have a common denominator. We need a 3 underneath both. So I'm going to have to multiply this left sucker by 3. Let's see what we get. 48,000. So we get 48. Is this 160 or... Oh, that's 100. I didn't do enough zeros. Hold on. 160 times 3. Oh, it's 480,000. Woo! I didn't do enough zeros. Okay, 480,000 pi over 3 plus 256,000 pi over 3. Okay, now let's go ahead and add these numbers on the top, and then hopefully they'll divide by 3. Let's see, 480,123 plus 256 equals, divide by 3. Okay, so I added the 480,000 plus the 256,000, then I divided by 3 and it gave me a decimal. So, poop. I can't use that decimal. So instead, let's add this 480 plus that 256, and we have 736,123. 736 was 3 zeros, pi over 3. And I wish we could divide those to make it a whole number, but we can't. I tried. Hey, that's the volume of this crazy picture. and it's centimeters cubed because volume is three-dimensional. Okay, let's look at this cylinder. It's a it looks like a cheese, wheel of cheese. Okay, V equals pi r squared h is a cylinder. So let's do this. V equals pi r squared h. Okay, r is from the center of the circle to the outside, 9. H is that height, 5. And then we slap the pi in front. Okay, let's multiply this. This is pi times 81 times 5. And let's see what 81 times 5 is. 405. 405 pi. We're in centimeters. We're cubed because volume is three-dimensional. All right, next sucker. It looks like we got a pyramid-looking thing going on. Okay, let's look at our formulas. The pyramid-looking thing is V equals LWH over 3. All right. V equals LWH over 3. Okay, and it looks like the L is the front piece of the base. So 4. The width is the depth, how far you go back, crooked. So how far we go back, crooked, is another 4. Height goes from the tip-top point straight down to the middle of that base. And we have the tip-top point straight down to the middle of that base. So that's the height. All over 3. Okay, there's no pi's because there was no pi in the formula. Okay, now let's multiply this. I think you get 64 over 3. And if you try and divide that, it's disgusting. Ugh. Decimal. So let's keep it dirty, just like this. 64 over 3. And it's centimeters cubed because volume is three-dimensional. Uh-oh, what do we got here? Okay, we got to find the volume of this barn. What? Okay, well, let's see. First, we got a rectangle-looking thing on the bottom. That rectangle-looking thing on the bottom, his formula is length times width times height. Okay, so the box-looking thing, that's going to be length times width times height. Because it's this box-looking rectangular prism kind of thing. Okay, so length is across the front, along the bottom. Height is up and down. Width is how far we go back. Okay, so length is the 40. Up and down is the H. How far we go back slanted, it's kind of in a different spot. But no matter what, whatever slanted measurement we have going back, that's going to be the W. Okay, so for the box, we're going to have, let's see, 40 times the W, 35, times the H, 14. And we get 40 times 35 times 14 equals, let me do that again, 40 times 35 times, you guys got to check me, 40 times 35 times 14. Whew, okay, finally did it right. 19600. And there ain't no pi because there was no pi in this little formula. Okay, now let's find the volume for this tent, this thing on top. Okay, the volume for this thing on top, a tent, is BHL over 2. BHL over 2. Okay, we got to figure out what this B, H, and L are. Okay, the B is how long the base of that triangle is. So let's look at our triangle. How long is the base? Well, it's the same as the 40 below because those two lines are parallel. So our base for this tent is going to be 40. Okay, the height for this tent is going to be this 5. And then the L is kind of awkward. What am I looking at? Oh, I'm looking at the L, which is how long that rectangle going backwards is. Backwards. So, my rectangle is here, and I'm looking for how long it is. This piece right here. That is going to be the L of the tent. Well, this piece right here is the same as the piece on the bottom. So the L is 35. That 11 is useless. They gave it to us to trick us. So our tent volume is 40, the base, times the height, 5, times the L, 35. And that gives us 7,000. Okay, now to find the volume of the whole thing, we take that 196 and add that 7,000. Hey, and we get 26600. And there's no pi, because there's no pi in the formula. We're talking about feet. And we're 3-dimensional. So it's cubed. All right, let's keep going. Let's look at this top right. It says find the volume of the right rectangular prism. Okay, well, rectangular prism is volume equals length with height. Icky. Okay, well, our length is across the front along the bottom. So 5. Height is up and down, but let's check all my up and downs to see if there's a number. So far, not good. Oh, it's this last up and down piece. That's the H. Okay. And then how far back we go slanted, that's the W. So this time, when I go backwards slanted, the W is 6. Okay, so let's multiply those together. We're going to have length 5 times W. 6 times 2. Yeah. And that makes 30, 60. And we're in centimeters. Whoops. And we're cubed. All right. Okay. Let's look at this last guy. It kind of looks like a milk carton or maybe a barn or maybe a church with a little steeple on the back. Yeah, okay. Or that was a cross. My bad. I meant whatever. Anyway, don't listen to me. All right, so we're going to find the area of this thing. Okay, let's start with maybe this little triangle. Let's see what shape this triangle makes. It looks like that made a tent. It kind of looks like a tent. Yeah, so let's use that formula. Volume equals base height length divided by 2. Okay, so I think I'm just going to write small tent. Okay, the formula was base times height times L divided by 2. And when I'm talking about a tent, I'm talking about like a tent that you camp in, you go camping in, or the tent that they put on top of a wedding outside when it's raining. Yeah, okay. Anyway, so our base is across the front of that triangle along the bottom. So our base is, does it even say? I think I can see it. I think it says 12. Yeah. Okay, so 12 times the height. the up and down of that triangle, which is really tiny, but it says 7. And then the length, that's how far back we go. Well, how far long or how far back is the same slant as down here on the right, 56. So my L is 56. This is 56 long, or feet. Okay, so let's multiply this. 12, 7, and 56. So I'm going to multiply the top. 12 times 7. 4704 divided by 2 is 2352. Almost ran out of room. 2352. Okay. Now let's look at this trapezoidal prism thing. The trapezoidal prism is this middle shape that's right below that tent, but on top of that rectangular shoebox. So the trapezoidal prism is not this little bitty tent piece, and not this rectangular prism. That trapezoidal prism is what's in between those two. It's this white piece right here. Okay, and that white piece says, there's an extra formula down here, and it says L1 plus L2. Well, golly, we got to figure out what those are. Okay, L1 is how long the base of that trapezoid is. So let's look at our trapezoid. Here it is. And how long is it across the front? Well, it's the same as how long the bottom is, 46. So our L1 is 46. Okay, let's figure out L2. L2 is how long the top of that trapezoid is. So how long is the top of this trapezoid? Did they tell us? I think they said 12. So if we're looking at this shape right here that I'm coloring pink, the top is 12 long because it points to it. The bottom is 46 long because it's parallel to that bottom piece. Okay, let's figure out where the 56 goes. 56 goes on the, whatever that is, T? Can't really tell. Okay, let's figure out, and it's 56 because it's 56 long. Yeah, or that might be an L, I can't tell. Okay, now the H. H is how high up and down this prism is. And you can't really tell. I colored over it, but there's a up and down line right there. That's the height of that trapezoid. So 5 foot is the height of that trapezoid. I'm just going to write it down here. Okay, and then now the only thing we don't have is that A. So we have to figure out what that slant is. We have to figure out what that slant is. Okay, well, we can figure out what that slant is because it's a triangle and it's probably something to do with the Pythagorean theorem or something. Or let's see, do we even need that A? Oh, we don't even need that A for our formula, so let's not use it. Okay. The volume for the trapezoid, we didn't have to label that A. Huzzah! The volume is, let's see here, L1, which was 46, plus L2, which was 12. all over 2 times the height, which was 5, times the t, which was 56. Okay, let's deal with this fraction first. This makes 58 over 2, and that makes 29 when you divide it. 58 divided by 2 is 29. Then we have times 5 times 56. And we get 8120. So that's for the trapezoid. Not this little blue tint on top, but all of this pink purpley color. Okay, now let's find the rectangular prism thing. This yellow thing. It looks like a box, like a shoebox. So if we go, we see our shoebox. The formula is length, width, height. Okay. So, on the shoebox, the length is the front piece. So, 48. The width is the slanted back piece, how far deep we go back. That's 56. The height is the actual up and down piece of the yellow rectangular prism, so 26. And then let's multiply those together. And we get 69888. Okay, now to figure out the whole thing, we're going to add. You can't see that. To figure out the whole thing, we're going to add those 3 numbers. From the tenth, we got 2352. From the trapezoid, we got 8120. From the rectangular prism, we're going to add 69888. And let's see what we get. I got 80360, and we're feet, and we're cubed because we're 3-dimensional. Woohoo! Done with our notes.